Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Olaoluwa and I'll be taking you through physics. Now I want to talk about the particle nature of matter. In this topic we'll be considering the structure of matter, look at the simple nature of molecules and atoms. We'll try to look at an experiment to determining the size of a molecule. Also, we'll look at evidences of particle nature of matter. And we'll talk about energy and kinetic theory one more time. Then we'll look at the states of matter. What is matter? Matter is anything that has mass and occupies a space. Now, the funny thing is, anything you can think of fits into the place of matter. Everything apart from vacuum, actually. So, when it comes to the structure of matter, it is noticed that in every component in itself is an entity of itself, and it is made up of tiny particles of its own self. Tiny particles that when you keep breaking down, you keep breaking down, you keep breaking down, you get to a point where there is nothing to break down any longer. If you have a piece of chalk, you grind it, and you grind it, and you blend it, and you can see just tiny specks of chalks all over the place. That is even in a very tiny form. But the tiniest form of matter comes to the level of it being a molecule, and we have the one that we describe as also the atom. The atom is the smallest part of an element that can take part in any chemical reaction, while the molecule is the smallest part of an element that can naturally exist on its own. In a few seconds, some questions will pop up on your screen to see how far you understand what we've talked about so far. Welcome back. Let's look at determination of the molecular size. There was a man called Lord Rayleigh. He did this experiment. He wanted to determine the size of a molecule, and he said the way to determine the size of a molecule is to put olive oil and let it spread. Put it on the surface of something so it can spread, and you can actually take the measurement of the thinness of the olive oil spread across the water. For this thing to be done, for you to be able to differentiate where the olive oil is and where the water is, and for everything not to mix up into each other, the lycopodium powder was introduced into the whole setup. How is this setup done? Water is kept in the tray. The lycopodium powder was sprinkled over the water, and a drop of olive oil was dropped. The olive oil kept spreading across the lycopodium powder until it formed the thinnest possible film it can form across. Now, the width or the radius of the spread was measured using a ruler, and also the volume of olive oil dropped was noted also, because a syringe was used to drop the olive oil. Now, a calculation was embarked upon to determine the thinness, that is the thinness of the film is taken to be the size, the size of a molecule. It was believed that each of the molecules of the oil arranged themselves, instead of stacking up on each other, they arranged themselves horizontally, lying across the powder. So the formula, you knew the volume of lycopodium powder applied, so the volume of olive oil rather, the volume of oil, and you also calculated the area of the spread, that's the area of oil. Of course, we all know that volume equals area multiplied by height. So whatever height would be gotten would account for the height of the molecule, that is the thickness of the molecule. Now, the volume of the oil, when you are dropping a oil from your syringe, it drops as a sphere, just like a ball, and the volume of a sphere is calculated by 4/3 pi r cube. Let's take this r as the volume, as the radius of the sphere. And also, the area of the spread, it was measured with a ruler. It was a circular spread, so can be pi r squared. Now, the radius of spread is not the same thing as the radius of the dropping. Now, our h, we can simply call it the thickness of molecule. So we can calculate the thickness of a molecule using this formula. When we take this to the other side, we have 4 pi r cube divided by 3 pi r squared. Pi can cancel out, so we have 4r cubed over 3r squared. So it was with this expression and this experiment, he argued that he was able to detect the size of a molecule. There is an argument about matter being in particulate form. That is, matter being particles made up of many particles which combine each other together to form what we have today. Well, here are the evidences that we have to prove and back up our arguments. We have the Brownian motion. A scientist, a researcher by name Robert Brown conducted a research, and he discovered that particles of a gas were moving, and this motion, he observed that they were random and irregular, and that was how they were named. That was how the phenomena was described as the Brownian motion. The Brownian motion simply suggests that even in the gas molecules, they have particles. Even in the gas, they have particles which are in constant motion, such as present as well in the liquids and solids. Also, the law of definite proportions. The law of definite proportion states that for any substance to be what it is, it must contain certain quantities of certain things. In other words, it says that for anything to be called water anywhere in the world, there must be the presence of 2 molecules of hydrogen and 1 molecule of oxygen. That is what forms 1 molecule of water. So it must be consistent. And we cannot start considering the presence of certain particles as such, certain items like that, unless there is the particulate form of every substance. Also, we have diffusion of gases, or diffusion of gases in gases. When you put a body spray, or you take an air freshener and you push it, the perfume comes out, and before you know it, it occupies as much space as possible. Things move from regions of higher concentration to regions of lower concentration. This is to show you that there are particles in that thing you call your perfume, which is going, and it is sensitized. That's why people who are at distances can sense the presence, can perceive the perfume. Considering all these evidences that we have, you see that even the kinetic theory supports it. The kinetic theory of matter, which we discussed in a previous topic, also supports this. It tells us that matter is made up of tiny particles. These particles are in constant motion. And this constant motion which these particles are in make them bombard each other, and a kind of attractive force is created. They possess kinetic energy. And at the end of the day, the closer they get to each other, the stronger the attractive force that is developed between them becomes. So, you see, energy comes to play again. It is not possible for you to talk about the existence of a matter without you mentioning energy. And when you even come to the states in which matter do exist, you see these energies come to play one more time. We have had time and over again that matter exists in three basic forms: the solid, the liquid, and the gas. Yes, in the solid, we see matter, some of us do wonder, we actually do see the particulate form of matter. We do see it as it has the chance of it being a particle. In the liquid and the gaseous states, well, since we don't see most gases, we do not know how to understand this. But today I'm here to explain to you some of the characteristics of these three states. In the solid state of matter, the particles are closely packed together. They are stacked together. They are compressed. That's why if a solid would, as much as possible, maintain its shape unless an external force do come to act on it. Because of the tight bond between them, they fuse together and they stay together. Unlike the liquid just adopts the container's shape. If you pour a liquid into anything, it will take the shape of whatever you're giving it, but it will not exceed the limits of its content. That is, it cannot exceed itself. That's the liquid. The liquid also contains its own particles. That's why you can take a drop of water, and even that drop of water can be further split into tinier drops of water. At the gaseous state, the kinetic energy is much high, so high that the molecules are in constant motion and they just occupy as much space as possible. If you take 1 kilogram of gas and you put it in a cup with a lid or in a small can, it would occupy the entire space. If you take that same 1 kilogram of gas and you put it in a much larger can, a can 10 times as big, it will occupy the entire space. Though the difference may exist in the amount of pressure which is exerted, and this pressure is also created due to the bombardment of the molecules of the gas. Taking more look at the gas. One of the reasons why we here have serious accidents when it involves gases is the fact that most of the time when we want to use gases, we use them under very high pressures. Take, for example, your cooking cylinder. Your cooking gas cylinder can contain so much gas. Your conventional cooking cylinder is supposed to accommodate maybe about 25 kilograms of gas. But you can pack as much as 50 kilograms of gas into it because the gas is compressible. You can force it to stay in. But should an accident happen, and there is a slight break, it will result in an explosion. Why? Because of the pressure that is inside the gas cylinder. So as easy as it can be to particulate and compress it, this pressure is induced due to the large number of particles. The larger the number of particles that you're putting into the cylinder, the larger the pressure that will be inside the cylinder. The same thing applies to tires of vehicles. When you drive your car is being pumped by the vulcanizer. When they pump it, it contains the pressure, it retains the pressure, and with that pressure, it is able to function. But when your vehicle is on high speed and the tire explodes, it actually distorts the driver. It makes the driver lose control because the pressure in there is so high and the gas molecules want to escape as fast as possible. So they, in their own way, push the vehicle in another direction of their choice. Okay, let's take a quick summary. Let's take a quick recap of everything we've looked at today. We talked about the particle nature of matter, and we talked about the structure of matter, that matter keeps breaking into tinier parts until you get to the atomic stage. An atom is the smallest particle of an element which can take part in any chemical reaction, while the molecule is the tiniest part of an element or a substance which can naturally exist on its own. We talked about the determination of the molecular size, that is the size of a molecule, considering the experiments Load relay, where you got water and put it in a bowl, sprayed on it laconium powder, then applied a drop of oil, olive oil. The olive oil spread, and he measured the radius of the spread. Now, to get the thickness of the molecule, he said the thickness of that film should be the size of a molecule. To get it, you divide the volume of the oil dropped by the area covered with the oil. Yes. Also, we consider the evidences that we have to prove the particulate state of matter. We considered 3 of them, and the 4th of them, or 4 of them. First thing we considered was diffusion of molecules of gases. We also considered the law of definite proportions, and we also looked at Brownian motion. Also, the kinetic theory of matter gives more insight into this, because the kinetic theory of matter starts by telling us that matter itself exists in particulate form. We also looked at the different states of matter. That's the solid state, the liquid state, and the gas state. The solids are tightly packed together, while the liquids are packed together, but they have a certain degree of freedom. As for the gases, they have unlimited freedom. Gases are, you can stack them, you can pressurize them, you can compress them to a very great degree. In a few seconds, some questions will pop up on your screen. Please try to solve them. And if there is anything you do not understand, you can go over this video one more time. Thank you.